What's up, guys? Welcome to day 12 of just trying to be a little bit smarter. And in this stream, I think what I'm going to do today is go through some of my Anki flashcards that I've been trying to get through for a while now. So let's do this. Probably spending 30 minutes on this, and then after 30 minutes, I'll probably start reading again for some of my classes. Alright, okay, let's study a little bit. So what is a space curve or curve? I think a curve is something that we learned about in Calculus 3. And this is just a line or maybe a shape, but I think it's more of a line that exists in space that is differentiable at all points. So it's a range of a continuous vector value function on an interval of real numbers. Oh, totally forgot about vector value functions. So vector value functions, these are functions that, okay, maybe we should start at the top. So a function just maps a set of numbers to a set of other numbers. And most likely, the most common functions we know of, they're real values, or real numbers to real values, to real numbers. And that continuous vector value function, let's just start with a vector value function. So then you map a real number to a vector, and then in the continuous case, there is, I believe, a continuous function or a continuous set of numbers that gets mapped to a continuous set of vectors. What that means is that if you were to just plot out the vectors on a graph, then they would be touching each other, I guess, at an infinitesimal, that's what the word is. So the distance between each point is infinitely small. Okay. Find the easiest way to set up the double integral of x cubed y dA, where R is the region in the first quadrant bounded by the lines y is equal to x and y is equal to 2x, and by the hyperbola xy is equal to 1. So y is equal to 1 over x, xy is equal to 3 times y is 3 over x. Okay, this one's interesting. So we have a double integral of a region R. So that'll be in the first quadrant. And then we have lines y is equal to x, y is equal to 2x, okay? So we'll have one straight line that looks like this, one straight line that goes up a little bit more. And by the hyperbolas, so y is equal to 1 over x. Oh, I think this might be the change of base variables. So what is the, excuse me, what does the double integral of a region represent? I think this will find the volume from the xy plane towards volume above the or below the xy plane for this region. So now I'm thinking that if we have two of these variables, so x is equal to uv, y is equal to v, then we can make this a little bit easier on ourselves. Alright, so if we let v is equal to u times v, that means v squared is equal to u. So u is equal to v squared. Then we also have y, so v is equal to 2 times u over v. To write this down. So let's write this down. No more battery left on this. Okay, this is taking a while, so I just see. V 1 to 3. Jacobian J. So I never fully understood what the Jacobian does. With the transformation T, we can try changing the coordinates to make our region more simple to integrate over. So y is equal to x, v is equal to u over v, y is equal to 2x, v is equal to 2 times u over v, xy to 3. So uv times u is equal to 3 by xy 1 uv. So this will just cancel out u. Okay. I think this might be the scaling factor that scales our original region to this region here. So there you go, we can set up is square root of 2u, square root of u, uv, okay, dv, du. So that's good for now. What are some potential uses for term structure models? When we talk about term structure models, I'm thinking of yield curves or term structure of interest rates. And so these are models that are functions of two things. So one is the day-to-day, and then also a function of maturity. And given the day-to-day and maturity, then it'll spit out an interest rate for a fixed income security, or maybe a yield. So an interest rate or a yield for a fixed income security that matures at some date in the future. So I think some potential uses then are for investors or traders to maybe model the prices of certain bonds using this term structure. In order to figure out the price of a bond, what you really need to know is the present value of the cash flows in the future. So that would be your coupon rates, and then also the present value of your principal. And within that present value calculation, you need to know the coupon payments, and then you also need to know the discount rate, or that's your yield to maturity. And that can be found within a term structure model. Mark-to-market assets. What is the instantaneous forward rate? So the forward rate is the idea of some type of interest rate you'll receive in the future. So what I mean by that is, let's say today interest rates are 5%, and 2 years from now interest rates are 3%. So a 3% interest rate is considered the forward rate, which is just the future interest rate. Now the instantaneous forward rate is, I think, the idea of instantaneous just means immediately. So this is the immediate forward rate or the immediate future interest rate. And by immediate, maybe it's a day or 2 days from now that you might receive on, let's say, a repurchase agreement or maybe some short-term borrowing. If you were to borrow, let's say, a day from now. It's the rate of return for an infinitesimal amount of time. So this is, save this right now. So forward. I feel like this could be better. Oops. Okay. Okay. So let's see. Reminder, the forward rates is the interest rates that one would receive in the future. Okay. This means for example, if when looking at interest rates today, so it's a big emphasis on today, can get, say, buy a zero coupon bond with a 5% yield to maturity. Two years later, when looking from today, the forward rate is forward is the yield to maturity. Zero coupon bond that we buy. The instantaneous forward rate is the rate of return. I feel like rate of return is interest rates for just rate for an infinite small amount of time. When looking at term structures / yield curves, these are continuous functions. Even though we usually care about maturities, maybe? Instantaneous forward rates is the small periods of time in the future. Can be thought of as future. Curves. These are continuous functions, even though we can instantaneous forward rate can be thought of as the interest rate between two very small periods of time in the future. So let's take a picture of the yield curve. Okay. What is quantitative easing? So I think the idea of quantitative easing refers to the Federal Reserve or central bank, in which the central bank prints a lot of money and goes into the market to purchase up a lot of treasury bonds. And so that is some type of monetary policy that kind of stimulates the economy a little bit. It effectively injects more money into the financial system and into our economy by buying up these treasury bonds, treasury bills. And then I believe there might be a target towards longer dated bonds, so maybe maturities of 20, 30 years. And I guess with a decline in supply, prices rise, and an increase in prices will push down yields and interest rates. I think that's the basic idea. Let's see. So this book talks about quantitative easing. I think this would be very helpful. Okay, so this is repurchase agreements. Okay. Squeeze the sponge, liquid flows out, let the sponge relax, and it sucks the liquid back up. Okay. That's actually a good metaphor. Trying to find my pencil. I can't seem to find it though. Let's see. sponge. Primary dealers in the banking system. Primary dealers in the banking system. See, it's just the 12 banks in the first deposit. She sees unemployment rising. Clearly, she needs to be more money in the system, so it's time to squeeze this sponge. Then it's time to squeeze. $50 billion. I'll give you back. Great, we're $50 billion more liquid, but what are we supposed to do with all this cash? Well, we can't keep here. No one's buying from Fed funds right now. There's too much money in the system. Get up there. I need the home buyers in Washington. Okay. Take $1 billion. I can push up and just. Now any bank that hasn't got enough cash coverage is going to have to pay a bit more. Okay, so I think this definition of quantitative easing is a bit misleading. So I think this Man vs. Market's Patty Hirsch example is a bit better. Just want to confirm though. Print money. Okay. So, quantitative easing is a bit like printing money, but done in a way that's specific way that involves purchasing of treasury bonds than in the financial markets. Per cash. Oops. Purchasing of treasury bonds in the financial markets. Goal of what is the goal of QE is to inject extra money into the financial system. Okay, so there's a debit account. So I think that's cash receipt. Just crediting a bank account. out of thin. Purchasing bonds with money that doesn't exist. Okay, so I think the big idea of quantitative easing is just, it's a bit like printing money where you're injecting more money into the economy, but the way it does this is through the process of purchasing treasury securities, treasury bonds in the market, usually from prime dealers, prime brokers. And so the goal is to create extra money is to inject extra money into the financial system, pretty much out of thin air, through the process of purchasing treasury securities with money that doesn't exist. How does I think, yeah, this is probably not works when, so say the way it works. Okay, maybe that could be another. Okay. So I'll just not flag the card anymore. Like printing money specific way involves purchasing treasuries, financial markets. The goal of QE, so the goal of quantitative easing is to inject extra money into the financial system, pretty much out of thin air with the Treasury, not the Treasury, but with the Federal Open Markets Committee going into the market and purchasing treasury securities or bonds or other types of debt with money that doesn't exist. What factors are used to determine the growth rates of real estate value? So I think the factors used to determine the growth rates of real estate value, they're going to be the house prices. So, okay, first of all, when looking at real estate value, I think we had built some type of formula or function that can determine real estate value, I think based on a few different variables. One of them was the growth rates. I think the second was the expected return or the expected cash flows. And then also the cost of capital. So I think what we had done was we had used the dividend discount model to kind of value what a real estate property would be worth based on the cash flows, the growth rates, and then the required rate of return or the cost of capital. So in this case, when we think about the growth in real estate value, there's a few factors that kind of go into this variable G. And that's going to be the increase in the housing price. So just an overall increase in the value. It's going to include the reinvestments that are made into the property itself. So this could be maybe a new appliance or maybe a completely new garage, new basement, or a new part of the home or property. I think those are two main ones that I can really remember. Let's see if there's more. Appreciation. Okay, right. So then you could also have maybe a decrease in the value of your home through depreciation. Okay. investment, house price appreciation, right? Okay. What is preferred habitat theory? I think this is the idea that whenever you're purchasing or in the market to buy these fixed income securities, for whatever reason you prefer some specific type of maturity or some specific time frame for your cash flows. I think one of the best examples for this is when you're, let's say, a mortgage lender, and your mortgages are paid. People pay mortgages. Actually, let me think. Maybe you're a property developer and you take out mortgages in order to fund some new construction projects. I think maybe on the capital market side and your financial activities, the property developer will look to use some of its excess cash to purchase mortgage-backed securities or any type of fixed income security that has cash flows every 12 months, which match up with the payment schedule for the mortgages it currently has outstanding for the properties. I think that's what preferred habitat. Okay. I prefer specific investments, specific maturities, payment periods, right? For example, life insurance companies funding annuities want to have coupons and principals match up. Okay. How can a term structure model value fixed income securities at multiple payoffs at different points in time? So remember again, a term structure model is just another word for a yield curve or term structure of interest rates. And so when we're looking at fixed income securities, that mature at different points in time, we can use a term structure to find out the yield that we would receive starting from today for holding security until, let's say, 5 years from now, 10 years from now. And so with whatever maturity our fixed income security has, we can find the corresponding maturity within a term structure. Okay. So let me rephrase these questions. So what are the term structure outputs term structure model? What are the inputs to build a term structure model? So think interest rates here. Okay. What is the first order condition for a quadratic optimization problem using matrix vector notation? So, okay, the quadratic optimization problem is, I believe, just the idea of having some type of optimization problem that takes or resembles the sum of squared errors. And so usually what we're doing here is we're taking, let's say, a sample and we're subtracting by our prediction, and then we just square that number. So that's going to be the sum of the squared, that's going to be a squared error, and then we do this for all of the possible samples, so now we have a sum of squared errors. And the first order condition just means we're finding the first derivative or the first order of this function, this quadratic optimization function. So I think using matrix vector notation then, let's say we have okay, so I think what we have is a vector of true observations, and then we have a vector of coefficients, and then we have a matrix of what we call feature vectors or observations. Okay, maybe a vector of labels is a better idea. So a vector of labels, a vector of coefficients, and then a matrix of observations. So it'd be 1 by n, n by m. So we have 1, 2, 2, 2 by 2, 2 by 2. We have a 1 times 2, 1 plus 1 matrix multiplication. So it has to be that'll be 2 by 3. Okay. One by 2, 2. Okay. So I think if we take the derivative of, so let's say y minus xy hat squared, so that'll be our just normal optimization problem. And then we take the derivative maybe with respect to y hat, which is our vector of coefficients. Then we have to use the chain rule, so I think it will be 2 times x times y minus xy. Let's see. Oh. Okay. Oh, nice. So this is where we got x. Yeah. Man, I'm hungry. So, okay, I get this part. This is what I was talking about, but I didn't. Oh, right, it's negative x. First order condition of the quadratic optimization problem should resemble taking the first derivative to the vector of weights b. Okay. Here we have the following variables. So I believe y is equal to the true labels values. Okay. And then we have x is equal to matrix of observations. Oh wait, we should also do, say, m by n. One vector of true labels slash values. Vector of weights coefficients. Transpose. So now we're going to need to multiply that together. I feel like maybe we just add it to. So double check here. Okay. Save. Yeah. This for now. Say this is where I stop for now, and then probably continue back on this either later today or tomorrow, but this is where I need to figure out why there was 2 missing here and look into that. But yeah, it's a problem for another day. I think studied 8 cards in 8 minutes today. Wow. Yeah, that's not great. Because I did spend a lot of time trying to review these flashcards, make sure they were pretty good. Alright. How do I exit out of this? Oh, here we go. Sync. Okay. And I'm very hungry. Wait, maybe F11. Okay, let's quit. Nice. All right, in that case, gonna go eat some lunch for now. I'm really hungry, so I'm gonna go do that, and then I'll come back and start probably some of my write-ups, honestly, because it's probably the biggest thing I need to do right now for work, for school. But yeah, that was a okay flashcard sesh. I feel like I got bogged down into the details of quantitative easing a little bit, so that kind of hindered me of progressing, but I think that's okay. I think the flashcards that I went through today, so one of them was about the double integral of a region and using a transformation to kind of make the integration easier. That was one. And then I think another one, a really important one, was the quantitative easing one. So what exactly is quantitative easing? I think Man versus Markets helped me a lot with Patty Hirsch. So there was that. So what is the goal of quantitative easing and how does it work? And then also there was the flashcard on the quadratic optimization problem and finding the first order condition. But I don't know how the 2 is missing, so I think I have to look into that. Alright, in that case, I'm gonna sign off for right now. Go eat some lunch, and I'll see ya in the next one. Alright, I gotta stop here.